All right, so overall pretty good. 2.5 was obviously the properties of algebra, right? So in questions like 1 and 2, we had to solve the equation and then explain each step. Just remember, so I grabbed Giovanni. Everybody's that I grabbed, I'll give you candy when I'm done, just remind me. Okay, so Giovanni, he's got his first step here. Remember that it's given. A lot of you skipped that first reason. Whatever's given to you, that equation that's given, you have to state that it's given to you, okay? You have to justify where it came from, and that one's given to you. Then you can do this in different order. Some people subtracted the 3x, and some people added the 5x. It doesn't matter which way you do it. You just got to justify that step. So he subtracted, and then he wrote subtraction property of equality. Okay, so the transitive and that kind of stuff you don't need it, but addition, subtraction, multiplication, division, you want to make sure that you add those on. You can even abbreviate that. So you could put POE for property of equality. If you want to, that's fine. But just make sure I can tell the difference between subtraction and substitution, because if you abbreviate those, you can't abbreviate them the same way. Okay, then came the next step, which in this case they subtracted 18, so subtraction property of equality. And then the last step was he divided both sides by -8, and that's the division property of equality. Again, you can go in different orders. So like some people subtracted the 18 first, or added the 38 first, and then added the 5x. It doesn't matter as long as you're justifying all those steps.
I skipped a step, like I did both of the adding at once.
Okay, as long as it's the same step, as long as it's the same reason, you can do them together like that. Yep. Okay, then the second one was -3 times x minus 5 equals 2 times x plus 10. So again, this first step should have been given. Then came the distributive property, distributed the -3 in here and the 2 in here. Then added on both sides the 3x. Again, you could have done this in a little bit different order, but who's this, Lewis? Yeah. Added, so addition property, don't forget of equality, or POE for those. And then he subtracted 20 from both sides. That's a subtraction property of equality. And then divided by 5 on both sides, division property of equality. Questions on that one? Okay, then came number 3, which said identify the property of equality. If the measure of angle 3 equals a measure of angle 5 and 5 equals 8, then the measure of angle 3 equals the measure of angle 8. This is the transitive property of equality. Good job, Brian. Most of you got that one right. And then, that's your transitive. Number 4 said if CE equals EF, then EF equals CD. We reverse the order on here, so that's symmetric. This was Christian's. And then the last one, if CE equals EF and AB plus CD equals 26, then AB plus EF equals 26. So the CD got replaced with the EF, which I stated in the beginning they were the same, which means you are substituting one in for the other, and that was Giovanni's. Again, a lot of you got that one right. Questions overall? So be careful, because this is also an if and then, kind of like your transitive property, but this is, you are taking something out and replacing it. It's not an if this, then that, and you're like joining the two statements together by taking something out. This is physically taking something out and replacing it with what it equals. Okay, so 30 said in the figure at the right, y or zy, which is this one here, is congruent to xw. So those were marked as congruent here and here. Okay, then it said zx, which is from here to here, is 5x plus 17. And YW is 10 minus 2x. And YX is 3. So you can take your, excuse me, you can take your 2, right, and say that if this part's congruent to this part, and I add 3 to this side, it would be the same thing as adding 3 to this side. So I can say 5x plus 17 plus 3, or no, sorry. 5x plus 17 would equal, did I label the wrong thing on the side? Why? No. 10 minus 2x. Because if I took this, made it congruent to this, and then added 3 to both sides, okay, it would be the same thing as adding 3 to both sides, then I know they're still equal. Does that make sense? So now I'd get, add the 2x, 7x equals, or plus 17, equals 10, subtract the 17, 7x equals negative 7, x equals negative 1.
Oh, I did plus 3, like 5x plus 17 plus 3.
Equals
10x.
Wait, 5x plus 17 goes the whole way, though. 5x, right? It's z all the way to x. So this segment, you needed the 3 to just know that you were adding 3 to both sides, which would keep it equal.
Okay.
Yeah. Then it wanted z, y, I've written all over this, which is here, right? So I had to take the 5x plus 17 and subtract 3 from it. So 5 times negative 1 plus 17 minus 3, negative 5. And that's 9. And then it should be the same the other side, but you can test it out as well. If I want just this part here, then I'd have to take the 10 minus 2x and subtract from it 3. So 10 minus 2 times negative 1, minus 3, 10 plus 2 minus 3, which again is 9. You just forgot to subtract the 3. Yeah, just be careful. Questions on any of the other homework questions? All right, we're going to move into 2.6. So 2.6 is proving statements about segments and angles. Remember we talked about proofs. Proofs are a way of justifying what you know about objects, shapes, equations, whatever it is. So eventually, not only are you going to have to tell me something about a diagram, you're going to explain why you know that, okay? And this is, it honestly is the most challenging part of geometry, okay? It's also the most frustrating part because it might take you a little while to get the hang of it. It's like a puzzle, basically. You know what it looks like at the end, but you got to figure out all the steps in between is the idea. So a proof, or a 2-column proof, is a logical argument that shows a statement is true. It has various formats, either a flow chart where you're drawing little circles with information and with arrows pointing to the other one, paragraph in which you're just describing it with your own words, and then the one we're going to use the most is a 2-column format. On the left side, you're putting your statements. On the right side, you're putting your reasons. So you did this with an algebraic equation already. Now we're going to do it with everything, algebra and geometry. So on the left is your statements, which is your given information or the result of applying a known property or fact. And on the right-hand side is the explanation for each of those corresponding statements. So if you think about how we just did all these algebraic equations, let's say it said 2x plus 3 equals 10, right? This was given. This is a 2-column proof. Here's my statement. And here's my reasons. So now we're going to number them. We'll get 1 and 1, and then 2 would be 2x plus 6 equals 10. So the reason for 2 is the distributive property. Then 3 would have been to subtract the 6 from both sides. That would be subtraction property of equality. And then 4 would have been to divide by 2 on both sides, and that's the division property of equality. So you were doing 2-column proofs without knowing it, okay? The difference is that you were doing them with an algebraic equation, and now we're going to do them with shapes and objects. So left side statements, right side reasons. All right, so what are acceptable reasons in a proof? The things that you can write on the right side. Obviously given can be from the actual statement, information they give you, or if you're given a diagram and you can write things about a diagram, all of those reasons would be given. Then you've got all the different definitions you've learned up to this point, all of the properties we've covered up to this point, all of the postulates we've covered up to this point, and all of the theorems that we've covered up to this point, and we're going to continue to learn more. So that's the stuff you can write on the right side. Okay, you can use all the properties we talked about. You can use the definition of vertical angles. You can use the definition of supplementary. You can use the postulates, all the ones we talked about that if, 2 points are on a line, then the line, or 2 points lie in a plane, then the line that contains those points is in the plane. Like anything that we've talked about so far, which means angle addition, segment addition, all those postulates can all be used. And then the same for the theorems. You're going to learn a bunch of theorems, okay? And once you start to learn all those theorems, you can use them in proofs. The properties of congruence that are applied to angles and segments. So we talked about these yesterday. The properties that we know about algebraic or numeric values can also be applied to angles and segments. Yesterday we called them properties of equality, and they're the same for properties of congruence. So the reflexive property says that any segment is congruent to itself, and every angle is congruent to itself. The symmetric property says that if DE is congruent to FG, then FG is congruent to DE. We can reverse the order there. And for angles, if angle A equals angle B, then angle B equals angle A. And then transitive was your if and then. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. And for the angles, if angle A equals angle B and angle B is congruent to angle C, then angle A is congruent to angle C. So the difference between these and values is now we're talking about the objects themselves and we're using the congruence mark instead of the equals. So pay attention to a couple of things on here. Obviously, you need to know your properties. But notice that the angles names all have the little angle drawn there. You either have to write the word angle or you have to draw that little thing on there. You cannot leave just A and B. Those are points, not angles. So be really careful with those. Make sure that you're writing the correct thing. All right, so example 1 says, write a 2-column proof for the situation in example 4 from the previous lesson. Given that the measure of angle 1 is equal to the measure of angle 3, prove that the measure of angle EBA is equal to the measure of angle DBC. And then it gives you the statements and it wants the reasons. So first, I always look at like what they're actually saying and does it make sense in my mind before I even get to the breakdown of the steps. So if this says that the measure of angle 1 is equal to the measure of angle 3, and those are already marked, does it make sense that the measure of angle EBA, which is this big angle here, would be congruent to the measure of angle DBC? Does that make sense?
Yes.
Why? The two little segments are congruent, right? So I already know that this one is congruent to this one. And then what happens when you go to the big angles? What was added into both of those angles? Angle 2. Yes? Everybody see that? Is angle 2's value going to change is the value of angle 2 going to change if you add it to angle 1 or angle 3? No, it's going to be the same, right? Because it's the same angle, yes? So if I add the same value onto two different angles that are already congruent, I'm going to keep it congruent. Does that make sense? So now we got to justify those statements. So the first thing that says the measure of angle 1 equals the measure of angle 3, where did that come from? It was given to you. So the reason for number 1 is given. Then number 2 says the angle EBA equals the measure of angle 3 plus the measure of angle 2. So EBA, which is this one, is the angle 1 plus the angle, angle 3 plus angle 2. And I wrote on top of it with the arrow. But what is that? Where's that come from? What's it called when we state that one angle is the sum of its parts? What's it called when we say that an angle is the sum of its parts? It came from before yesterday, so your brain has to think way back. When we add up two parts. Good. Yeah, angle addition postulate. Remember I told you you're going to use it a bunch? Here we come. Okay? So if I say that a big angle is the sum of its parts, that's the angle addition postulate. Oops. Okay, then 3 says angle EBA is equal to the measure of angle 1 plus angle 2. Is that from the diagram? No. So where did that come from? Connor, you have a guess? Yep. So you basically just said that EBA equals 3 plus 2, and then we took 3 and replaced it with the measure of angle 1, which we can do because we said they're equal, and that's substitution. Then comes the measure of angle 1 plus the measure of angle 2 equals DBC. So DBC is equal to the measure of angle 1 plus the measure of angle 2. Does that come from your diagram?
Yeah.
Yes. And what is that called? Angle addition postulate again. And then the last statement says that the measure of angle EBA is equal to the measure of angle DBC. How'd we get there?
I think symmetry.
You're close. So this is the hardest one because transitive is one object equals one object, and that one object equals a third object, so I join them together. This, which is really close, is basically taking the statement here that said, if this one equals 1 plus 2, and then 1 plus 2 equals DBC, then we can put these two together, right? Which seems like transitive, except that we're replacing two values. So it's substitution, okay? Transitive and substitution get switched a lot, okay? If you're replacing a single term by an if and then statement, it's transitive. But if you are replacing multiple ones like we just did, this is substitution.
So if multiple, then
If it's multiple or a value, like angle A equals 100 and angle B equals 100, so angle A equals angle B, that's substitution because you're replacing it with a value. If A equals B, B equals C, so A equals C, now it's transitive. Connor. For number 3? Yeah, so if you look at number 3, it says EBA, which is EBA, is equal to 1 and 2. But from the diagram, EBA is equal to 2 and 3. So if you're not using the diagram, it's got to come from someone else. Does that make sense? Okay, good.
I don't get why it's substitution.
So we took this statement, right, which says EBA equals 1 and 2, and this statement, which says 1 and 2 equals DBC, and we replaced the 1 and 2 with what 1 and 2 equals, which is EBA.
Oh, okay.
Does that make sense?
Yeah.
Okay. So on your first test, you're going to kind of baby step your way into proofs like this, where you're maybe given the statement and you have to fill in the reasons. Sometimes they're missing some statements, and then sometimes you're missing some reasons. Eventually, this would be a blank page, and you would give me both. My rule on proofs is I know they're hard. I know people don't get them. You have to try. So on your homework, do not leave it blank. Give me at least what you know about a diagram. Even if it doesn't always make sense to you, it might eventually make sense just by spewing all the information you know about it, okay? But blank proofs with just a question mark will not earn you credit. You've got to at least try. All right, example 2. Now it says write a 2-column proof, and now I'm looking at a segment. So it says given AC equals AB plus AB, prove that AB equals BC. First one says AC equals AB plus AB. Given. Do the easy ones, right? 1 is given. 2 says AB plus BC equals AC. Where did that come from? That's from my diagram, right? The two parts equal the whole. That is your segment addition postulate. Three says AB plus AB equals AB plus BC. Substitution. You took AC in this one and replaced it with what we just said it equals. And 4 says AB equals BC. We took AB plus AB, right? And replaced it with what it equals. And we took AB plus BC and replaced it with what it equals. What's that? Substitution. Oh, no, I'm sorry. We didn't replace it. That's not replacing. Just kidding. We didn't replace it. What did we do to both sides of this equation? Subtracted the AB away. Yes?
Yeah.
Subtraction. So you took from both sides of this equation and subtracted the AB. Questions on that one?
Wait, so like that thing statement 1 through 4 is like a problem to solve?
Sort of.
Because I thought it was like a different statement every single time.
It's a different statement every time, but it's all building. So the first one gets to the second one gets to the third one, or sometimes the third one comes from the diagram, but it's all built on the same pieces of information. So they're all connected.
So we were doing math.
Exactly. Yep. All right. This one said M is the midpoint of AB. Prove two things. A, that AB equals 2 times AM. And B, that AM equals 1/2 AB. So think about all the things that you know about what's already here. If M is the midpoint of AB, what does that mean?
That AM equals.
That these two parts are equal to each other, yes? Then does it make sense that this whole thing would be 2 times one of those parts?
Yeah.
Yes. Does it make sense that 1/2 of that whole thing would equal 1/2 of the whole thing? Yes, right? So now we've got to justify all those statements and reasons. So the first one says M is the midpoint of AB. What is that? Given. Usually the first one is given, but not always, okay? So don't just write given on the first one all the time. Number 2 says AM equals MB. So now we're saying that this part equals this part, and how do you know that? Definition of a midpoint. Right? If you don't know what midpoint means, you don't get to that statement. So definition of a midpoint. Three says AM equals MB. What just went from, what's the change from here to here? I went from congruence to equals. Yes, you see that? That's just the definition of congruent. Congruent to equals, or from equals to congruence. It's definition of congruence. Number 4 says AM plus MB equals AB. Where'd that come from? Does AM plus MB equal AB? Segment addition postulate. Five says AM plus AM equals AB. Substitution. We took the MB and replaced it with what we said it equaled. Okay, so now A says 2 times AM equals AB. So it's so close. If I take and add these two together, I get this statement, right? What's it called when we add on the same side? Simplify or combine like terms. I'll take either one. And then my last step, or that's A, 6A, 7B. AM equals 1/2 AB. What got you from 6 to 7?
7, 8, 9.
That's why 6 is afraid of 7, because 7, 8, 9, right? What is it? I heard somebody say it. Division, yes? Do we divide on both sides? Yep. Or multiply by the half. You could do either one, but division works. Division, property of equality.
So basically, like for most of them, it's just how you got from number 1 to number 2.
Sometimes it's just 1 to 2, and then 2 to 3, and then 3 to 4. And then sometimes it will reach back into previous information before the one before it, but it's still always like, how did I get to that step? So sometimes you got to combine more than one together to get there, but usually it is, yeah.
And the given means like you found it on the...
So given comes from 2 places, either a statement, like it literally says given like that, or if it directly comes from the graph, like let's say they were marked as congruent, so I said AM equals MB, that's given, because it comes from either the picture or the statement. Last one. Okay, just a wrap up. So writing a 2-column proof, here's some tips. In a proof, you make one statement at a time until you reach the conclusion. Because you make the statements based on facts, you're using deductive reasoning. Because what's the difference between deductive and inductive? Deductive is fact, inductive is pattern. Good. Usually the first statement and reason pair you write is the given information, but not always. So be careful. Don't automatically write it. Then it says the proof of the symmetric property. So this is actually like them proving that symmetric property is true. If I had 2 angles, like 1 and 2, in my diagram, and it said that they were equal to each other, that first statement's given. Then number 2 says the measure of angle 1 equals the measure of angle 2. So we went from congruent to equals. Remember, that's the definition of, in this case, we're talking about congruent angles. So it's definition of congruent angles. Then what happened? Switched sides. 2 equals 1. That's symmetric property. And then 4 went back from equals to congruence, which is the definition of congruent angles. Okay? So this, you can actually use proofs to prove the things you're going to learn about theorems. You just want to go through those steps as best you can.
And 2 and 4 also the definition of congruence.
Yeah, I'm not going to get that picky. So I don't know that I'll make you put the word angles on there. I think definition of congruence is close enough. Yeah. Okay, so you got to just do your best. Again, it doesn't mean you're going to get them right all the time. It might take you a little while to get the hang of this. But especially when they're giving you the statements and then the reasons are what you're filling in, it shouldn't be too bad. When they get blank, it's a lot more challenging. Okay, but for right now, you're just doing that. All right, your assignment's open on Canvas. Okay, again, you're not leaving anything blank. You're attempting everything. And try not to abbreviate in a way that I can't understand it. You can use abbreviations like the POE and stuff like that, but don't abbreviate in a way in which I can't understand it.